There's a traveler ripping past our sun that refuses to play by our rules. It showed up fast, brightened in unexpected ways, and then slipped behind the sun right when things got dramatic. We couldn't watch the peak from Earth. The glare swallowed it, so the world started piecing the story together from Mars-based cameras, deep space telescopes, and a flurry of papers that landed in months. The name is 3I Atlas, only the third confirmed interstellar visitor we've ever seen. And the way it behaves is forcing us to rethink what normal even means out there. Right now, the headline is simple: 3I Atlas just swung through its closest approach to the sun, perihelion around October 29th, but Earth missed the show because the comet was pinned near the sun's glow in our sky. That solar conjunction blackout sounds like bad luck, and it was for backyard observers. But professionals were ready. Spacecraft and distant observatories lined up to watch from safer angles, and that's where the story gets interesting. Start with the speed. Our planet hustles around the sun at roughly 30 km. Mercury whips along at about 48 km just to keep from sliding into the gravity well. 3I Atlas barreled in at about 58 km/s, fast enough that the sun can't keep it. That's a hallmark of an interstellar object, a hyperbolic path that arrives from deep space and leaves for good. Size estimates put the nucleus somewhere in the sub-kilometer to few kilometer range, bigger than Oumuamua, on par or larger than Borisov, and that's before you even add the fuzzy shroud of gas and dust around it. It also skimmed the ecliptic plane with uncanny alignment, a near side-on T-bone with our planetary disk rather than a dive from above or below. The geometry alone made astronomers raise an eyebrow, but the real plot twist came from the chemistry. Most comets we grew up with are water ice divas. They wake up inside 3 to 4 AU, sunlight warms them, and H2O vapor dominates. 3I Atlas didn't read that script. Early on, way out beyond Mars, its coma was driven by CO2, with a staggering CO2-H2O ratio near 8:1, the highest ever recorded. That's like opening your freezer and finding dry ice where you expected ice cubes. JWST and companion observations confirmed it. This visitor starts by venting carbon dioxide, and only later flips to stronger water outgassing as it heats up. In simple terms, it turns on earlier and in a different flavor than local comets. How early? We actually saw hints before discovery. NASA's tests caught it between May 7 and June 2, 2025. Long exposures stacked to reveal a faint mover, already getting livelier as it drifted inward, its flux rising, far more than distance alone would predict. That's a smoking gun for early activity, perfectly in line with the CO2-led story. And then there's the light itself. When sunlight hit Atlas's dust, it bounced back in a way that stunned the teams measuring it. Extreme negative polarization. Most comets give you a largely positive signature. Even the previous interstellar comet, 2I Borisov, looked normal in that sense. Atlas went the other way and did it more extremely than anything we've cataloged, pointing to dust grains that are not just unfamiliar, but possibly born in conditions we don't get around here. Think of polarization as the accent of scattered light. Atlas speaks with an accent we haven't heard before. Tail behavior only added fuel. Early in the approach, observers noted a sun-facing plume, counterintuitive if you imagine. The solar wind always blasting tails, away from the sun, but if CO2 is venting vigorously before the wind is strong at that distance, you can pile dust on the warm, sunward side before it gets combed back. As Atlas neared Mars's orbit, reports shifted toward a compact, fan-shaped tail and then post-perihelion, a tangle of features, multiple plumes, hints of an anti-tail depending on geometry and exposure. That complexity made headlines, and the louder the anomaly sounded, the faster speculation spread. October gave us a gift, the Mars window. On Oct 1 to 4, 3I Atlas slipped within a few tens of millions of kilometers of Mars. Cameras on and around the red planet pivoted. China's Tianwen-1 released a run of images, including a neat little GIF of a ghostly speck gliding frame to frame. ESA's ExoMars TGO and Mars Express also watched. Back on the ground, people spotted a Perseverance Navcam image with a slender streak likely matching the visitor. And then the drama. Chatter about unreleased high-rise shots from NASA's MRO, while Tianwen-1's public release set social feeds ablaze. Whatever the full story, the takeaway is clear. Planetary missions doubled as comet paparazzi, and the first public close-range looks didn't come from Earth. That's the science. Now the noise. As soon as you say interstellar and weird, the internet leans in. Commentators flag the brightness surges, the polarization oddity, and the tail puzzles as reasons to ask bolder questions. Harvard's A.V. Loeb and others argued for aggressive spacecraft follow-ups, and a U.S. lawmaker publicly pushed NASA to release all images. Meanwhile, some articles claimed no tail after perihelion, while others showed evolving structure. Bottom line, there's active debate and a lot of hot takes, but the data are still coming in, and the conservative read is unusual, not impossible. The physics toolbox, outgassing chemistry, dust microstructure, changing geometry can explain a lot without invoking sci-fi. Stay curious. Stay skeptical. Where did it come from? One analysis points to the Milky Way's thick disk, an older, sparser neighborhood above and below the thin, spiral plane, suggesting this object could carry dust. Recipes from the galaxy's cosmic noon, when star-making was fierce billions of years ago. If true, that's a time capsule drifting through our backyard. It's not just a comet. It's a sample of how other planetary systems bake their ingredients. What's next? Circle March 16, 2026. 3i Atlas will pass within 0358 AU of Jupiter. Multiple teams have floated trajectories to tweak. Juno for a closer look, leveraging a Jupiter-Oberth maneuver to pounce on the visitor. Even without a direct intercept, a coordinated campaign across Juno and other spacecraft could lock down composition changes after solar heating, check for fragmentation and nail dust physics driving that wild polarization. If there's a moment to trade speculation for measurements, it's that window. So what do we make of 3i Atlas? It's proof that weird is relative. Our solar system isn't the standard of the universe. It's one local experiment. Out there, comets can wake up on CO2, scatter light with never-before-seen signatures, and swing through on orbits that look suspiciously well-aligned simply by the luck of three-dimensional space. The rumors and the clicks will keep coming, but the real thrill is quieter. Every spectrum, every polarization curve, every frame from Mars or Jupiter chisels away at the unknown. That's the part worth chasing.